There are hundreds of DSA patterns out there, but one pattern appears in more interviews than any other. Sliding window. In this video, I am going to teach you sliding window completely. So after watching this video, you will be able to solve any sliding window problem you see in first attempt. Hello everyone, I am Sonia, 9 years as a Java developer. Let's go. Before I explain anything, let me show you why sliding window matters so much. This is the brute force to find maximum sum subarray of size k. Two nested loops big O of n square for every starting position. Check every possible subarray. Input size 1000, that's 1 million operations. Sliding window solves the exact same problem in big O of n. Input size 1000 operation. Same result 1000 times faster. That is why interviewers love this pattern. I have this array 2, 1, 5, 1, 3, 2. Brute force start at index 0. 2 plus 1 plus 5 sum is 8. Move to index 1. 1 plus 5 plus 1 sum is 7. But wait, you already calculated 1 plus 5 in the previous step, so you are recalculating. That's the problem with brute force, massive waste. Now if we are using sliding window says don't recalculate, just slide, never recalculate. Window starts at 215, sum is 8, slide right, remove 2 from left and add 1 on the right, sum is 7, slide again, remove 1 from left and add 3, sum is 9. Each element is touched exactly once, that's big O of n. That's the entire idea. Slide the window, never recalculate from scratch. Sliding window has two types, you need to know both. Type 1, fixed window. The window size is always k, given in the problem. Find maximum subarray of size k, fixed window. The window moves right, but the size never changes. Type 2, dynamic window. The window size changes based on the condition. Longest substring without repeating characters, dynamic window. Window expands when condition is met, shrink when it's violated. How do you know which one to use? If the problem gives you a fixed k, then fixed window. If the problem gives you a condition, dynamic window. Let's solve our first problem, maximum sum subarray of size k. This is an easy level problem and mostly Amazon asks this. Array is 215132. So build the first window 215, sum of first k elements. 2 plus 1 plus 5 is sum is 8. That's our first window. Set max sum to 8. Now slide the window. Remove the leftmost element, that's array of I minus k. Add the new rightmost element, that's array of I. New sum, that is 8 minus 2 plus 1 equals 7, and max sum stays at 8. Slide again. Now remove 1, add 3, new sum 7 minus 1 plus 3 is equals to 9, and 9 is greater than 8, so max sum updates to 9. Here is the Java code. First loop, build initial window of size k. Second loop, slide the window, add new element, remove old element. So one line does everything. Window sum plus equals array of I minus plus array of I minus k. So time complexity is big O of n and space complexity is big O of 1. This is the best possible. That's problem 1. Notice how simple the code is once you understand the pattern. Problem 2, longest substring without repeating characters. It is medium level and dynamic window, and Google asked this question mostly. And find the longest substring where no characters repeat. So we have input string is A, B, C. A, B, C and B, B. So we have two pointers, left and right. Both are at index 0. Right expands the window, left shrinks it when we find a repeat. So map right moves to index 0. Window is A and there is no repeat. Then right moves to 1. Window is AB, no repeat. Right moves to 2. Window is ABC, no repeat, length is 3. And right moves to 3. Then window is ABCA, A repeats. Violation, now move left pointer past the previous A. Left moves to index 1. Window is BCA, this one. Valid again. Now how do we know where the previous character was? Hashmap store each character with its scene index. When we find a repeat, just jump left directly to last position +1. Now map stores character to index. When repeat found, left equals max of left and map gets +1. Why max? To make sure left never moves backward. This is the most asked question, and now you know how to exactly solve this question. Now we have problem 3. Minimum window substring hard level. So don't be scared. The pattern is the same, just 2 steps. So step 1, expand right until window contains all characters of T. Step 2 is shrink left to make the window as small as possible. Now S is A, D, O, B, E, C. T is A, B, C. Expand right. So A, D, O, B, E, C. Now contains A, B and C, that is valid. Now shrink left, remove A, missing A, that is invalid. Expand right again and until we find another A. Shrink BANC, still contains ABC, length 4. So that's our answer. BANC still contains ABC and length is 4. The code is slightly more complex, but the idea is identical. Two hash maps, one for what we need and one for what we have. When formed equals required, window is valid, try to shrink. Hard problems are just medium problems with just one extra step. Expand until valid, shrink until invalid. That's it. 5 steps every sliding window problem always have. So one is initialize, set left to 0, set window sum to 0, set result to 0, set up all variables before the loop. Second is expand, move right pointer, add element to window. Window grows with each iteration. Step 3, check condition. Is this window valid? And check size equals to k. For dynamic, check your specific condition. Shrink. When window violates condition, then move left pointer, remove element from the window. Step 5, track result. After every valid window, update your maximum and minimum result. That's it. 5 steps works for every single sliding window problem I have ever seen. Tip for beginners: before writing any code, write these 5 steps in your IDE as comment and fill in the details and you will never get stuck. Let me show you 4 more problems all solved with the same 5-step template. First one is fruit into baskets. It is medium level problem and you can only hold 2 types of fruits. Find maximum fruits. Find longest subarray with at most 2 distinct elements. Dynamic window. Hash map tracks fruit counts. Second problem is longest ones after replace. It is also medium level problem. So replace at most k zeros. Find longest subarray of ones. So trick is window size minus count of ones must be less than or equals to k. This is also dynamic window. Let's go to problem 3. Permutation in string, that is also a medium level. Does S2 contain permutation of S1? S2 and S1 are string. Window size is fixed, exactly S1 length, fixed window with hash map. Let's go to problem 4. Maximum consecutive ones, that is also medium level, and flip at most k zeros, same pattern as longest one. 4 different companies, 4 different problem statements with one pattern. That's the power of learning patterns instead of memorizing solutions. Let's recap everything we covered today. 1. What sliding window is? Slide the window, never recalculate from scratch. 2. Two types: fixed window when k is given, dynamic window when condition is given. 3. 3 complete problems, easy, medium, hard, all with Java code. 4. The 5 steps template: initialize, expand, check, shrink, track. 5. 4 more problems, all follow the same pattern. Now you know sliding window completely. The next time you see any problem about subarrays, substring or consecutive elements, your first thought should be, can I use sliding window here? 9 times out of 10, yes. Now here is your homework. Go to LeetCode right now and search for maximum average subarray, problem number 643. Solve it using these 5 steps template. Then come back to this video and comment, did the template work? I want to know. I read each and every comments. If this video gave you clarity about the sliding window for the first time, please subscribe to this channel. Next Sunday, I probably going to drop complete deep dive for 2 pointers. Same format, same depth, full Java code.